Hi, everybody. We're going to be trying to present lessons this way going forward, so you get the opportunity to um, still get me to teach. Um, so it feels kind of like what class would feel like for us. Okay, so today's lesson is going to deal with radian and degree measure, and we're going to take a look at a lot of definitions and a lot of terminology that we're going to use when working through the unit on trigonometry. So to start with, and by the way, I'm going to post like my notes for this on Schoology, so you guys will be able to follow along with this lesson. And there are some additional examples on my notes. So just keep that in mind going forward. If you want to print that out before you run through this lesson, that's okay too. Okay, so to start with, an angle is formed by rotating a ray about its endpoint. So if you guys look down below, I've drawn a diagram of what an angle looks like. And if you look at the angle itself, it kind of looks like a cursive letter O, which is the most common symbol that we use in math to denote angles. It's what's called theta, Theta. So that's our angle. And then the starting position of the ray is the initial side of the angle. The position after rotation is called the terminal side, and the end point of the ray is the vertex of the angle. So the vertex is going to be where the initial side meets the terminal side. And then if you look at the angle itself, I have an arrow that is moving in a counterclockwise direction. So I put that arrow to indicate the direction of rotation, which is important because depending on which way we rotate our ray is going to correspond to a positive angle measure or a negative angle measure. Okay, so next thing we want to do is we want to look at the most common way that you'll see angles drawn, and that is what is called in standard position. So if you look at the coordinate plane to the right, if we want to draw an angle in standard position, for an angle in standard position, we have the initial side, which is going to be located on the positive x-axis. The vertex is going to be located at the origin, and then we're going to rotate that ray either clockwise or counterclockwise, making the terminal side. So I can draw the terminal side like this. Again, we're drawing that arrow indicating the direction of rotation, and our angle measure theta is going to be that entire angle there. Okay, so as I mentioned earlier, depending on the direction in which we rotate, that's going to dictate something about our angle. So that tells us whether we have a positive angle measure or a negative angle measure. So positive angles are going to correspond to a counterclockwise rotation. And negative angles are going to correspond to a clockwise rotation. Sorry, that's my son screaming in the background. So if you guys hear that on your end. Okay, so again, if we rotate in the counterclockwise direction like we've done for both of the angles drawn up above, those are going to correspond to positive angle measures. And if we rotate clockwise, that's going to correspond to a negative angle measure. Okay, so we have two ways that we're going to measure angles. In this class, I would say the majority of the time we're going to work in radian measure, but from what you guys have done in the past, I'm sure you've worked exclusively in degree measure. For those of you who go on to take physics, you work more in degree measure in that class. In pre-calculus and in calculus, we almost work exclusively in radian measure. So we're going to talk about those two measures and the relationship between those two measures. Okay, so let's get into that relationship. So I've drawn a circle, or what's supposed to look like a circle, to the left, and we know it takes 360 degrees to make one full revolution or one full rotation around a circle. Okay, so what we're going to do is we're going to define a radian as the measure of a central angle theta that intercepts an arc S equal in length to the radius r of a circle. Okay, so let's go ahead and draw what's being described there. So the way we make a central angle is we're going to go to the center of the circle, and then we're going to draw two radii. Okay, so again, a radius, which plural is radii, is going to be the distance from the center of the circle to a point on the circle. So we're going to call that length r. And I'm going to draw another another radius here. So that distance is also r. And then a central angle is going to be this angle measure here, theta. And what this central angle is going to do is it's going to cut out like a certain portion of the circumference of a circle. So it's going to cut out this portion here of the circumference of a circle. Okay, so what the definition is saying is that if the arc that is cut out, which we're going to call that arc length S, if that arc length is equal to the length of the radius of the circle, then that means that our central angle theta is going to have a measure of 1 radian. Okay, and you guys are going to see, like as we develop the relationship between radians and degrees, 1 radian is going to be about 57 degrees or so. Okay, so the way we can actually compute the measure of a central angle in terms of radians is using the following ratio. So if we take the arc length S that central angle cuts out, and we divide that by the radius r of the circle, then that's going to give us the measure of that central angle theta in terms of radians. Okay, so with that said, if we make one full revolution, around the circle, if you think about the arc length that's going to get cut out by one full revolution, that's going to be the distance around the circle, which is the circumference. And we know that the circumference formula for a circle is 2 pi times the radius r. If we divide that by the radius r, then one full revolution around a circle is going to correspond to 2 pi radians. So what that does is that gives us the relationship between degrees and radians. We know that one full revolution around a circle is 360 degrees. And that's going to be equal to one full revolution around a circle, which is 2 pi radians. And if we take both of those values and divide them by 2, that tells us that 180 degrees is going to be equal to pi radians. And that's going to be an important relationship for us going forward. It's going to help us be able to convert between degree measure and radian measure, which is what we're going to look at next. Okay, so we have conversions between degrees and radians. So if we're going to take an angle measure in terms of degrees, so I'm going to write theta in terms of degrees, and we want to write that angle measure in terms of radians, the way I like thinking about this is like how you would go about doing unit conversions in chemistry. So I want my units for degrees to cancel. So I want to have a degree in the denominator and a radian in the numerator. And we know that pi radians is equal to 180 degrees. So I can write pi in the numerator and 180 in the denominator. So if I want to convert from degrees to radians, I take my angle measure in degrees and I multiply it by pi over 180. Similarly, if we want to go from radians to degrees, we have an angle measure theta in terms of radians. So we want to have the unit radians cancel in the denominator, and we want a degree measurement in the numerator. Again, we know 180 degrees is equal to pi radians. So if we want to go from radians to degrees, we take our angle measure in radians and multiply it by 180 over pi. Okay, and that's going to give us the corresponding angle measure in terms of degrees. So as you guys see, like I'm kind of like introducing the terminology now, and then we'll work through some examples involving all of this stuff in the next video. Okay, next thing we're going to look at, again, is something that you guys should be familiar with what you've learned in the past. So we're going to assume, so that symbol that kind of looks like a fish, that's another commonly used symbol in trig, that's alpha. And the symbol that looks like a B, that's another commonly used symbol in trig for angle measures, that's beta. So we're going to assume that alpha and beta are positive angles. Statement number 1 says that alpha and beta are complementary. Okay, so those two angles are complementary if the measure of angle alpha plus the measure of angle beta is equal to 90 degrees. And we can take 90 degrees, and if I multiply it by pi over 180, that's going to become pi over 2 radians. Okay, and the two angles alpha and beta are supplementary if the measure of angle alpha plus the measure of angle beta is equal to 180 degrees or pi radians. And again, with this definition, both angles alpha and beta have to be positive. Okay. All right. Next definition is dealing with coterminal angles. And you're going to hear this phrase pop up a bunch in this unit. So coterminal angles are angles whose initial and terminal sides are located in the same position. Okay, so again, they're angles whose initial and terminal sides are located in the same position. And the way we go about finding coterminal angles is we add or subtract multiples of 360 degrees or 2 pi radians. So if you look at the diagram I have down below, I've drawn an angle alpha in standard position. And if I want to find an angle beta that is coterminal with that angle, so I'm going to go ahead and draw this angle beta in green. So the initial side is going to be in the same position. The terminal side is in the same position. If I take like one full rotation around the circle, and then come to that ray right there, that angle beta is coterminal with angle alpha. And beta's relationship to alpha is that beta would be equal to alpha plus 360 degrees if we're talking about degree measure, or alpha plus 2 pi if we're talking about radian measure. And I can keep like adding multiples of 360 or subtracting multiples of 360, and those are all going to give me angles that are coterminal. The initial and terminal sides are going to be in the same location. Okay, next thing I want to do is I want to look really quickly at each of the 4 quadrants. So I've labeled the 4 quadrants as so. Again, quadrant 1 is the top right area, quadrant 2 is top left, quadrant 3 is bottom left, and quadrant 4 is bottom right. And then what I want to do is I want to take a look at angle measures that are going to lie in each of the 4 quadrants. Okay, so if we look along the positive x-axis, if we have angle measures of 0 degrees, or 360 degrees, or 0 and 2 pi, the terminal side for that angle is going to lie along the x-axis. Okay, so I'll go ahead and draw that in green here. If we have an angle that looks like this, that would have a measure of 0 or 360 or like a multiple of 360. If we have an angle that looks like so, where the initial side lies on the positive x-axis and the terminal side lies on the positive y-axis, that angle measure is going to be 90 degrees or pi over 2 radians. If we have our terminal side lying on the negative x-axis, that's going to correspond to an angle measure of 180 degrees or pi radians. If we have the terminal side lie on the negative y-axis, that angle measure is going to be 270 degrees or 3 pi over 2 radians. And then if our terminal side again winds up being on the positive x-axis, that's going to be 360 degrees or 2 pi radians. So what that does is it gives us like a range of angle measures that is going to lie in each of the 4 quadrants. So if our angle measure is between 0 and 90 degrees or 0 and pi over 2 radians, our angle lies in quadrant 1. If it's between 90 and 180 or pi over 2 and pi radians, the angle lies in quadrant 2. Between 180 and 270 or between pi and 3 pi over 2 radians, the angle lies in quadrant 3. And then if our angle is between 270 degrees and 360 degrees, or 3 pi over 2 radians and 2 pi, the angle lies in quadrant 4. Okay, so 2 more things for us to go over. Number 1 being the Pythagorean Theorem. So I'm not going to spend time going over this. You guys have seen this a ton going through your math classes. So it says in a right triangle, the sum of the squares of the 2 legs is equal to the length of the hypotenuse squared. So if you have a right triangle like so, if this leg here is A, the bottom leg is B, and the hypotenuse, which is the side opposite the right angle, is C, using the Pythagorean theorem, we can say that A squared plus B squared is equal to C squared. So the sum of the squares of the 2 legs is equal to the length of the hypotenuse squared. Okay, last thing for us to go over are 2 special triangles that are going to be really, really important for us as we move through this unit. So the first one being a 45-45-90 triangle, which has a special name in math. It's an isosceles right triangle. So it's isosceles because the 2 angle measures 45 degrees are the same, which makes the sides opposite those 2 angle measures the same. So we can call those side lengths x. And the side opposite the right angle, the hypotenuse in a 45-45-90 triangle, is going to be x rad 2. Okay, it's really, really important that you know that going forward. And then the second special right triangle is the 30-60-90 right triangle. And in a 30-60-90 right triangle, the shortest leg, which is the side opposite the 30-degree angle, is going to have a length of x. The longer leg, which is the leg opposite the 60-degree angle, is going to be that shorter leg x times rad 3. And then the hypotenuse, the side opposite the right angle, is going to be 2x. And again, those 2 relationships are going to be really important going forward when eventually we look at the unit circle, as well as reference angles and reference triangles. So you'll see these angles or these special triangles pop up again as we move our way through this unit. Okay, so we'll stop there for now and then move on to some examples with the next video.